instead, we're going to look at how to carry out simple approximation. Then that includes both whole numbers and decimal numbers. So I'll be sharing the screen with you right away so that you can give you the topic for today is approximation of numbers. So you could be given certain numbers and asked to approximate it to certain degrees. Let's start with whole numbers. Whole numbers. So if you're given whole number, like let's look at examples. First one here. Let's say question 1. Say number 1. Approximate the following. Approximate the following to the specified degree. Specify degrees. So let's say the first one is given like 2,614, that to round it up to 1, round it up to 2 significant figures, then 2 nearest 1,000. And 3, I want to round it up to the nearest 10. Nearest 10. Just focus, because after this I'll give you what to do, and if you're not focusing on this, you're just busy writing, I'm going to help you. So here now, this is the number I have. I want to change it to 2 significant figures to the nearest 10, nearest 1,000. Yeah, if I'm talking about significant figures, I'm talking about figures with highest value. You can see 2, 6, 1, and 4. The one with the highest value is 2 because it's in 1,000 place. It is 2,000. And the 6 is 600. While the 1 there is 10. And the 4 is just ordinary 4. So the highest value there is 2. And that is the most significant figure. So if I am looking for 2 significant figures, I'll just pick the highest 2, which are the 1,000 and the 100. That is 2,600. Now, it's only 2 digits I want to see. That's just the 2 and the 6. But I'm not going to change the value of this number to 26, but I'm simply going to change it to 2,600. Why 2,600? Is because when I stop on 6, the next figure is 1. It's not able to power 6 to become the next digit, which will be 7. Let's assume it's 2,658. Yeah, that's 5. You can power 6 to become 7. Then 2 significant figures would have been 2,700. But anything after that second digit, which ranges from 0 to 4. So 0, 1, 2, 3, and 4. If they are here, it will not tamper with the value of my 2 significant figures. But if it's 5 and above, it's going to tamper with it. So to this particular answer now, to this particular question, so the answer becomes 2,600. Rounding this up to 2,600 that means it's to two significant figures. Okay, let's look at the second one. Nearest 10. I just told you about the place values of each of the digits. Units, 10, 100, and thousands. So the one in the position of 10 is 1, and that is where I'm stopping, nearest 10. So I have 2 and 6, then 1. This 1, that means I'm using nearest 10, and that is going to give us 3 significant figures in this case. So the nearest 10 is 1. It's under this 1, it stops at 1. Again, the figure after 1 is less than 5, so it can't affect the 1. So I just simply have my 1 and put 0 as next. Had it been is 5 and above, it should have changed the 1 to become 2. Change the 1 to become 2, that would be 2,620. So, to the third one, third question. Let's assume, okay, right, let's space. So to the third question, I have nearest 10. Okay, that's the third one. That is nearest. So let me change this to be to the nearest, what's it called? Nearest 1,000. So this is the third one I've just solved. So let's solve the second one here. Second one is nearest 1,000. Yeah, following nearest 1,000, the figure that is 1,000 there is 2, not 6, not 1, not 4. The figure that is 1,000 here is 2. So this is 2,000. I could have written 2,000. Yes, you said what?
It's not 1,000, it's not 100.
Which one is 100 that you are asking about? Which? This number 2 says. This says what?
So the nearest 100.
This is nearest 1,000. Okay.
Okay.
So nearest 1,000. Now to the nearest 1,000, I have 2 to the 1,000. So the 2,000, that is where I'm stopping. But because the figure after 2 is greater than 5, so from 5 and above can power it. So I have 3, 0, 0, 0. So it's going to become 3,000 to the nearest 1,000. So I can say for the number 1, 2,614 becomes 2,600 to the nearest two significant figures, which is, I could say, it's nearest 100. That's the first one, because it is this 100 that is where I stop. Then the nearest 1,000 is like saying one significant figure. So I'm stopping on the first one because it's a 4-digit number. So one significant figure or nearest 1,000, I stop on the 2, and this one changes to 3. Every other thing to 0. Then the third one says nearest 10. So for nearest 10, stop on the third digit, which is the same thing as saying 3 significant figures. Now, over to you to finish out this number 2. Number 2. So approximate. So you can put this down now. Put the note down. Approximate the number low to specify degrees. To the specified degree. So here's the number, and let me call that B. So here's the number. Let's say you have something like 16,300. Okay, let me undo that one. 16,739. Want to round it up to the first case, which is nearest 1,000. Nearest 1,000. Then to the second case, which is nearest 10. And to the third case, which is 1 significant degree. So you have a few minutes to do this and tell me your answers to each and to the 3 of them, so that we can move to the next heading under this. So what's your answer to the first one? Nearest 1,000?
So I'm copying this one. Okay, so I want to say two.
Yes, what is your answer to the first one? What do you call it?
1,700.
1,700. Okay, what's the next one?
I'm not, this is like to tell you the first one. I'm not the second.
Okay, what's the second one? Just look at it and tell me.
So, is 4,000. So let me just do it, please.
I'm waiting. Yes, I'm waiting.
I'm coming. 16,740.
Okay, 16,740. So what is the last one?
So, yeah, what is it? It's 20,000, which is 20,000.
That is 20,000. Yes, I could have said you get everything right, but for the first one, you didn't get the first one because you were not patient to convert it. It is the 1,000 there is 16,000. So nearest 1,000 should be 17,000. Then you said 1,700. So take note of that next time. Okay? Okay.
Yes, sir.
Yeah, take note of that. So that
yes,
is 17,000. Yeah, because I left the link on and you were trying to join since it was not working, the time for the particular class is running down. So I will cut it now and resend the link. Not for English, we are still on mathematics. Is that taking? So I will resend the link. Just message mommy and ask for the link for the link that I said I'm resending link for this mathematics class. So when that's finished, I'm going to be sending for English class. Okay, so just stay tuned and wait for the link, or you just message mommy and request for it. Yeah, what were we discussing before?
We're talking about approximation.
Okay, yes. Rounding up of numbers, approximation of whole numbers. Now, what to approximation of decimal numbers. I'm going to be sharing the screen with you as well. We can look at that. Approximation of decimal numbers. You know your decimal numbers is 0 point anything or 1 point anything. So I'm going to be looking at it, and we're going to be seeing in which way it will be asked to approximate them. So we look at examples here now. Examples. Round up the following to the specified degree, or approximate following to specify degrees. Okay. See question 1 there. So the first question, round up round up 3.6058 to 8. 2 decimal places. B, 1 decimal place. C, 4 significant figures. And D, nearest hundredths. This is hundreds, not hundred. So take note of that. Like I said, it's better to focus on this than just write. So please focus on it. Now, the number is 3.6058. I want to round it up to 2 decimal places. 2 decimal places simply mean 2 places or 2 digits after decimal. We have 4 digits after the decimal, so we're going to stop on the second one. So I have 3.60. But because I'm stopping at 0, the 5 is able to turn it to next digit. That's going to be 61, not 60. Then nothing will be there again. Even if you turn the 5 and 8 to 00, it still makes no difference. So it's better not to put the zeros there. Take note of that. But if it were to be whole numbers and you stop at a second digit and there are other digits that turn to 0, the zeros must be there. Otherwise, to change the value of your number. This value has not really changed. It is still 3.6, it's still 3.6. Okay, to 1 decimal place. Yeah. So to 1 decimal place now, I have 3.6. If 2 decimal places mean 2 places after the decimal, then it means 1 decimal place is just 1 place after decimal. So that's going to be 3.6. Now 3.6. It's 3.6 because the next one is 0 and it cannot change 6 to 7. So 6 remains there. Again, the 000 that is next there, you can't put them because it doesn't make any difference to your numbers. Then the next one says you should round it up or approximate it to 4 significant figures. 4s. That means, note, we are not talking about 4. So I'm trying to admit that. So the next one is to the nearest 100. And this is different from normal nearest 100 that we did here. So here now, rounding up this to the nearest 100 simply means you are going to count after decimal. After the decimal, there is no unit. The first is tenths, then the next is hundredths, then thousands and tens of thousands. Tenths, hundredths, thousands, and tens of thousands. So as I have this, I'm talking about now nearest hundreds, that is two decimal places. So I'm stopping on this zero. And again, it's the same as the first question. So this is going to be 3.61. So you can see that two decimal places for this particular number is the same thing as nearest hundreds, because two decimal places end at second decimal, and nearest hundreds also end at second decimal. So I can see Tracy trying to join, or I have approved her about 3-4 times here now, but it should have been that once she joined the first time, she should have waited. She should not click repeatedly trying to join. Right, like right now, I can see three Tracy's that are showing here, and the three are trying to join. That means she's conflicting herself in joining. Anyway, the video is trying to get to her. So I'm going to write another example here. That's when she watches, she's going to get what I'm talking about. Now, number 2. You round up. I think she has sent another notification to join her. Keep admitting her, and she will be obstructing herself using the same phone to join about 5 times or 7 times. So, the next example is round up this particular number, that is 0.8705.
Yeah, still doing it. Leave it.
So, can you hear me now, Tracy? I just heard you now. Can you hear me now, Tracy? Okay, I continue. So, to round up this number to specify degrees now, let's say the first one, we're going to round it up to the nearest whole number. Nearest whole number. Then the second one, say nearest thousands. Nearest thousands. Nearest thousands. Then to the third one, I can say one decimal place. One place. So, solution to the nearest whole number. You know your whole number range from 1, 2, 3 to million. No point. So if I want to remove this point, I want to stop at this first digit. I don't want anything after point. This 8 is big enough to power this. If it has been between 0, 1, 2, 3, and 4 that's been here, it's not going to change this. Then our answer would have been 0. But now that it's 8, it's just going to be 1.0, but I don't need the point because I'm talking about a whole number. Then the second one says nearest thousand. Again, like I explained the other time, this is tenths, hundreds, and thousands. This is thousand, this is 0. So I'm going to stop on that 0, but the 5 can change 0 to 1. So I have 0.871 as my answer. And finally, so the nearest one decimal place. So I'm stopping on the first digit after decimal, and this is going to be 0.9. Why 0.9? So 0.8 initially, but 7, that is after 8, can power 8. From the next digit. So that is where I'm going to be rounding up the class on website. So I'm going to send link first for English class so that okay, she's trying to join now. Let's see. Have here and if I said in this explanation, then move to the next subject. Okay, now since the connection is not working, I'm going to be skipping this class now. Then she joins again English. So put it on record for you. So, like I said, we will be looking at ratios and proportions today, and I'm going to bring up the question so that you can contribute into the answer. So, ratios and proportions. Ratios and proportion. So the question that I brought forward the other time is this. It's about ages of three brothers. So the problem one said the average age of three boys is 25. So now you have to find the age of the youngest, given the proportion of their ages. You can see the question, right?
Yes, sir.
Okay. So, like I said, from this question, what are the ages of the boys?
25.
Can you come again?
So I said 25 years.
I said, what are the ages of the boys?
3, 5, and 7.
Are those actually the ages?
The average ages of the 3 boys is 25.
So, were you given the ages at all? That's my question.
No.
So why are you giving me 25? Why are you giving me 3, 5, and 7? So what does 25 stand for? Third what? What does 25 stand for? Yes, I'm waiting. Tracy, I'm waiting to hear from you. What does 25? What's the meaning of 25 in this question?
I think that it stands for the average age of the 3 boys.
So, how do I get the average age of the 3 boys? That is what I'm asking you now. Yes? I'm waiting. Anyway, just look at this. Just look at this. Just look at this. Just look at this. And make sure you concentrate. From the ratio given, we're given ratio 3, 5, and 7. That means the ages of the 3 boys can be 3x, 5x, and 7x. So whatever x is going to determine their ages. Now, it's my job to find x. Your job to find the x. So how do you find x? You add all these ages together, which are 3x, 5x, and 7x. Then, you divide the answer by 3, finding the average, and that average is already given as 25. In that way, you have a fraction or an equation that can lead you to finding the value of x. And once you know the value of x, just multiply it with the smallest of the ratios to get the age of the youngest boy. So you shall see that in the solution that I'm about to bring out here now. So we want to find the value of x, and how do we do that? We are going to add all the ages together. So the average age has been given to 25, and the meaning of average means add the 3 ages together, divide the answer by 25. So this is 15x plus 75 by multiplying. When you multiply 3 by 25 or 25 by 3, get 75, then divide both sides by 15. That x equals 5. X equals 5. So the average age. Now let's find the age of the first boy. The age of the first boy is to multiply x by the smallest of the ratio, which is 3, and this is going to give us 15 years. So that means the age of the youngest boy is 15 years. So that is the question. That's the solution to that number one. Then the second question comes here. Second question comes here. The ratio of the number of boys. Let's look at the second question.
Sir, can you? Sir,
What is it?
I was. Don't worry, I've already
Now, have you seen what is on the screen now?
Yes.
Okay, so tell me if you understand it. Yes, do you understand it?
250. Okay, right. So, okay. Yes. So, 75.
You said what? What do you say? Let me hear you, yes? Okay, look at this. You have 3x plus 5x plus 7x. That's 15x over 3 equals 25. So use the 3 to multiply the 25 by cross multiplying. You have 75. Is that taken now? Is that okay? Yes, Tracy, is that okay now?
The thing was, I don't know what's wrong with this network. When you explain it to work. But I have it said.
So is that okay now? So that's 3 times 25 gives us 75. So here comes the next question, which should be problem 2. Then 2. Here is another question. So this is for you, Tracy. Tracy, I want you to do this and tell me your answer. Okay?
See the question.
Yes, look at the question. The question is here. So can you see it now? Can you see the question now?
I wasn't. I can see it now.
Okay, now
The ratio.
go through the question. Okay. Whether you can see it or not, let's go over to the solution because of our time. Go over to solution. So the ratio of the number of boys to the number of girls in a school is 720. Of 720 students is 3 to 5. If 18 new girls are to be admitted in the school, find how many new boys must they be admitted so that the ratio of the number of boys to number of girls may change to 2 ratio 3. Now, in that case, we have been given the ratio, and the sum of the ratio 3 and 5 is 8. So we need to know how many boys are in school, how many girls are in school, before we can talk about the new ratio. So here now, some of the given terms in the ratio is 3 plus 5, which is 8. Take note of that. Some of the given terms in the ratio is 3.5, which is 8. So the number of boys in the school will be 3 over 8 times the total population, while the number of girls in the school will be 5 over 8 times the total population. So take note of that as well. We're going to bring out that solution here to the side. So what I'm saying is the number of boys in the school will be given by 720 times 3 over 8, while the number of girls in the school will be given by 720 times 5 over 8, and this gives me these numbers respectively. So here now, we want to see new girls admitted. So given that the number of new girls admitted is 18, so let X be the number of boys, that we can use that to calculate the new number of boys. The number of boys. So let's bring that answer up. Bring that steps up. So I wish this screen is kind of. So now, given that the new number of new girls admitted to the school is 18, so let X be the number of new boys admitted. Then after the above new admissions, number of boys in the school now become 70 plus X, and the number of girls become 4 plus 18. 4 plus 18. I'm going to mute you now because of the noise. So that is what I do. Now the next step is to use the ratio that we were given, so that if we divide the 270 plus X over 468, it's going to give us 2:3. Then with that, we'll be able to find the value of X. So finding the value of X, let's see what that brings. Here, find the value of X. So here's the step here. So this is it. Say, oh, I think I need to shift this a little bit. Yeah. So you can see now, even the ratio after the new admission is 2:3. Then we have 270 plus X, which is number of boys, ratio 468, which is number of girls, equals 2:3. So you can cross multiply and say 468 times 2 equals to 3 times this bracket. Then you're going to have this when you open the bracket, then you have 3x plus and x is going to be 42. So you can say the number of boys must be admitted into now 42 in order to balance that ratio. Number of boys to be admitted of this. Number of boys to be admitted. So let me try to divide this page. You can see how it works. How it works. See. Here is the question here. So here is the beginning of the solution. See, solution begins here. Then cut across this line. Then cross this part again. From here to here. Then from here to here. And from here downward, then here's the final answer. So take note of that when you are about to put down your answers. I'm going to clear the screen now and bring up probably one more question, then we close the class for today. Okay. So the ratio of the prices of 2 houses was 16:23. So let's look at this third problem. It should be problem 3. Talking about ratio and proportion. The ratio of the prices of two houses. See, three. Yes, clear the screen. All drawing. So here is another question. So the ratio of the prices of two houses was 16:23. 2 years later, when the price of the first has increased by 10% and that of the second by this amount, $477, the ratio of the prices becomes 11:20. So find the original price of the first house. Find the original price of the first. So from the given ratio, we're going to work out the price of the house. From the given ratio, we have 16:23. Then the original price of the house is going to be 16x, while the original price of the second house will be 23x. So let's have that solution here. So here now, it says from the given ratio 16:23, original price of the first house will be 16x, while original price of the second house is 23x, 3x. And after the increment in price, the price of the first house will be 16x plus 10% of plus 16x, which is 16x, so that's 17.6x. Then for the second house, after the increment, the price will be 23x plus the amount that it's used to increase. So we can now find our x or compare that ratio. Now let's see. We'll compare that ratio. We find our x, then with that we can use the x to find the price of the first house, the original price of the first house. So let me see if this is going to contain this page. So here now, this is what I have. Okay, it's not going to. Oh, so the price of the second house is 23x plus 477. That's the increment. Then after the increment, price is the ratio of the become 11. So that's 17.6x ratio 23x plus 477 equals 11. So here we use cross multiplying to find our x. So when you find your x by collecting that terms and dividing by 99, you have x equals 53. Then the original price of the first house is 16x, which is 16 times 53, and that is $848. $648. So that is the price of that's the original price of the first house, $848. Just take note of that. So, and that is where we're going to be rounding up this aspect. Before I send you another link, I send you another link for English class for this evening. So thank you very much for being in touch. I'm going to have the lecture video later.
Chapter 14, verse 27.